Hello, everyone. I'm Oded Bental, speaking from London, and it is my great pleasure to welcome, I think it's the seventh Spotlight Talk, no, the eighth Spotlight Talk of this conference from Mary Simoni. She has several musical interests: composition, analysis, synthesis, and performance. Her work today spans her work in composition, analysis, synthesis, and performance with an influx of AI and generative system for music composition. Mary currently serves as a professor of arts and dean of humanities, arts, and social sciences at Rensselaer Polytechnic Institute in Troy, New York, and she is professor emerita at the University of Michigan, Ann Arbor. And she provided Bob with a video, so he will play that. And then when he is done, Mary will join us here on the live session and we'll take some questions.
Hello, everyone, and greetings from New York, where it's a beautiful fall day. For my talk today, I'd like to discuss me and my colleagues' work in applications of artificial intelligence for music analysis and music generation, and ways that I've used generative models or algorithmic composition in my own work. And because we're going to span a lot of territory here in a short period of time, I'm just calling this an AI mashup. But before beginning, I want to thank the team at the Royal Institute of Technology, and specifically Bob Sturm, for his tireless hard work in bringing us all together under these really difficult circumstances so that we can have this timely exchange of ideas. To begin, I'd like to establish an historical context. AI is proceeding through a continuum of developments. At one end of the continuum is narrow AI. Our goal is to move toward the other end of the continuum towards generalized AI, and beyond that, super AI, AIs that are as smart as we are, or even smarter. Narrow AI is designed for a specific application domain, such as business or medicine, or application in the arts, as we've seen and heard at this conference. Things like music composition, music analysis, and timbral analysis. Because the domain of music is so highly specialized, our collective efforts today I would classify as narrow AI. In the early days of AI, narrow AI was referred to as an expert system. We saw expert systems that utilize rules and pattern matching algorithms to analyze and generate music. The current capabilities of computer systems, coupled with big data, have given rise to machine learning algorithms that may be classified as either supervised learning, unsupervised learning, or reinforcement learning. The earliest example of use of a computer to compose music was the Iliac Suite for String Quartet that was composed by Lee Jaron Hiller and Leonard Isaacson 64 years ago. Hiller's work had many influences, including information theory, serialism, studied with Milton Babbitt after all, indeterminacy, and computer-assisted decision-making. He was fascinated by the computer's random number generator. Hiller and Isaacson applied compositional rules to shape the musical output of the computer so that it could be subsequently performed by human musicians. Many researchers have applied rules to generative music systems. One such example are the strict rules of species counterpoint, eventually codified in the 1725 treatise Gradus ad Parnassum by Johann Fuchs. Having clearly defined rules for music composition seems irresistible to many computer scientists and programmers, since algorithm formation encodes the rules so that there's no need to worry about this messy business of human creativity. One such example of a rule-based algorithm is Palestrina by Mary Farbood and Bernd Schoner. Their system applies Markov chains to model the rules of species counterpoint to generate music that's in the style of Giovanni Palestrina, a 16th century Italian Renaissance composer. My first entree into AI some decades ago was through the programming language Lisp, coupled with the motivation to understand the generative music software called Common Music that was developed by Heinrich Taube. Perhaps the most well-known expert system that uses pattern matching algorithms is David Cope's Experiments in Musical Intelligence, or EMI. His system searches for patterns across the repertoire of a composer, searching for salient patterns that may be elevated to what Cope refers to as a signature. Here we see two of Cope's numerous Lisp functions called first n and break into patterns. Cope uses MIDI data as input to his system. Here we see the results of an intervallic analysis so that the system may parse the data, searching for intervallic patterns. Although the results of EMI sound impressive, I have not been able to fully recreate the system despite access to all of the source code. Shifting gears to machine learning, my colleagues at Rensselaer Polytechnic Institute, Professors Curtis Bond, Jonas Brosh, and Matthew Goodhart, with doctoral students David Dahlbaum and Jeremy Stewart, developed an unsupervised machine learning system with financial support from IBM. This system, called MIKA, stands for Musical Intelligence and Knowledge Agent, is a compositional tool that extends the harmonic vocabulary of jazz-based music. For our initial work, we focused on the 12-bar blues. The 12-bar blues were realized via MIDI playback using Band in a Box, and then a script was written to transpose the MIDI to all 12 keys so that the system could be key agnostic. The input to a bidirectional neural network is symbolic, time-ordered MIDI data representing over 5,000 jazz performances of a 12-bar blues progression in 4/4 time, taken from the real book. The bidirectional neural network outputs an harmonic analysis that is a succession of chord symbols, for example, B9 sharp 11. And those chord symbols then are passed as input to a variational autoencoder. The VAE may predict the completion of the harmonic form or provide novel and stylistically appropriate chord substitutions. If you'd like additional information on the system, please refer to our paper presented at the 2019 International Computer Music Conference. Today, I'd like to share with you a couple of examples from MIKA. The first is input to the MIKA system, the 12-bar blues. And now the output of MIKA, that is a semantically valid and novel chord progression. I hope you enjoy it. All right. Okay, shifting gears to my own work, I was interested in exploring the relationship between traditional common practice Western music theory and atonal music. Specifically, the question I wanted to answer is if the repetition of a set of pitches that are uncharacteristic of the common practice period could assume the function of a tonal center based solely on repetition. I chose the set 3/5 based on Alan Fort's The Structure of Atonal Music, comprised of pitches here C, F, G flat, which in its prime form is 0, 1, 6. The interval vector of this set is intriguing to me because it only contains 3 intervals: a minor second, a perfect fourth, and a tritone. This implies that intervals that are not present in the interval vector, such as a major second, minor third, or major third and their inversions, could be used as contrasting material to the tonal center. The resultant composition is called Kanamara, named after the very beautiful region in Ireland. It's a 6-minute work for piano and live electronics. This excerpt of the opening section establishes set 3/5 as the tonal center while juxtaposing intervallic variation to transform the harmonic movement and recontextualize the set as tonal center. The symbolic material for Kanamara was composed using Lisp and Common Music, and the live electronics are realized in Max MSP. This composition was premiered some years ago at the Center for Computer Music and Research and Acoustics at Stanford University. And here's what this excerpt sounds like. Currently, I've just started a composition for piano quartet. So the instrumentation is violin, viola, cello, and piano with optional live electronics based on data sets that are related to the global pandemic. I began by mapping a portion of the virus's RNA, which has nearly 30,000 elements, onto a melody that begins the composition. Adenine, cytosine, and guanine are mapped to their initial pitches of A, C, and G. Thymine is mapped to musical attributes that begin with the letter T, such as turns, trills, tenutos, or triplets. Durations are based on the sequence. For example, when guanine appears twice in succession, the pitch G is given a duration of 2. In this case, in this particular moment in the piece with quarter notes, that means that it's equal to 2 quarter notes. Borrowing from Cope's terminology, the resultant melody, even though it's a fraction of the viral strand, serves as a shorthand signature of SARS-CoV-2. Here's a MIDI rendition of what that theme sounds like. Okay, this image represents the temporal plan of the macroformal structure of the first 4 minutes of this work, which will be around 8 minutes long. These 4 minutes tell a story with SARS-CoV-2 data. Initially, the violinist comes into rehearsal, asymptomatic, but as you can see in purple, shedding the virus. The virus then subsequently spreads to the cellist, violist, and then the pianist at staggered time intervals, each receiving the same viral load. Viral propagation through the ensemble will be treated compositionally as a fugue, with the SARS-CoV-2 theme as the fugue subject. And you can see here it's coded in purple. Although COVID is quite serious, The SARS-CoV-2 theme seems musically harmless. It's diatonic, it's rhythmically straightforward, it's actually compositionally purposefully innocuous. Eventually, each performer receives a positive PCR test that's coded in blue here, concluding the exposition of the fugue. They all come back, sadly, positive. From there, each performer has a unique response curve to the virus. So here we see the violinist has a severe case. This person is highlighted in red. The violist has a mild case and a different response curve, highlighted in yellow. The cellist, who sadly has an underlying health condition, but fortunately receives an autoimmune treatment that eventually moves to a kind of a mild case. The pianist receives an antiviral treatment soon after diagnosis and has the mildest case of all. I don't want to say here that I am a pianist, and I actually had a little bit of conflict of interest here in the format of this particular composition. The remaining 4 minutes, not shown here, use AI and generative methods to model each performer's response to the virus. Each period of illness will be modeled as SARS-CoV-2 attacks the unique DNA of each performer. Following illness, each performer has their own period of recovery. Fortunately, the way this piece is mapped out now, each performer is restored to full health without any complications at the conclusion of the composition. This piece is slated for premiere at Cambridge University's Center for Music and Science in January. And I want to do a shout out to Chrissy Nanu, who facilitated this particular collaboration with Cambridge University Center for Music and Science. At this time, I'll be delighted to take whatever questions or comments or whatever discussion we may like to have. Thank you very, very much.
So thanks, Mary, for the talk. And I will be monitoring, I think maybe both of us will be monitoring the Slack channel for any questions. Maybe I will start with one. Some of the processes you described, like the mapping of the DNA to the music, to the theme, and working out the kind of procedure for the piano piece, how the basic intervallic material gets rendered. Probably they're kind of arbitrary decisions. Can you talk a little bit about the, I mean, finding what works? Is it about the process of finding within this vast array of possible mappings what works for you, or how do you work with it?
Yeah, so I was trying to stay true to the sequence as much as I could, and so that meant AC and G stayed AC and G. Although I don't think that's going to happen in the fugue. I think the fugue subject's going to modulate and things, but and then from there it was like, what do I do with? I mean. So, you know, then I'm just like, okay, well, how could I represent that while staying true to the sequence? And that's where I came up with tenuto trills and et cetera. And whether to choose, you know, a turn versus a trill, those things were all quite subjective. After listening to the you know, the sequence a couple times over, I'm like, okay, that would work here. And I am trying to give it, I knew right away I wanted to treat it in a fugal way. So I wanted to have it so that it had enough melodic identity that I would be able to do that.
And maybe, I mean, one of the things that people talk about that AI systems or any machine learning system can help is this maybe time-consuming process of identifying a lot of options, and then instead of kind of going through them, do you see, if that was possible, do you see that working within your kind of composition work process?
Yeah, that's a great question. And quite honestly, working with specific instruments that have their own sets of constraints, and the fugue subject itself being so short, I didn't really see a need to use a computer to generate possibilities. I'm just working within the constraints of, in this case, a violin. I will do that, however. I don't know exactly how, but in terms of getting past, the initial PCR test, what will happen to try to merge, what I want to do is map individual DNA onto the virus, each with its own individual response curve. So there will be a lot of modeling that has to happen with either generative systems or machine learning. And then I will choose what I think is most valid in terms of the constraints of the instrument, but also what it is that I'm trying to tell in this story.
We have a question from Roger Dannenberg about applying tonal music models to atonal or other contemporary practices. He said, it seems to me that atonal is far from random and should receive more study and modeling.
That is, in fact, one of the main points of Fort's work, is that atonal music, if it's codified based on set theory mathematics, is really not random. That there are many of the same kind of traditional compositional practices in atonal music that are observed in the way that composers write tonal music or other music. So, in fact, that's what I was trying to explore in the piece Kanamara, specifically. I hope I answered your question, Roger. Nice to see you on the Slack channel.
Any other questions? Hopefully, maybe. I think it is maybe I'm imposing my thoughts, but I think it is interesting, this idea that you took the idea of tonal and non-tonal, or tonal and tonal center and opposite, and instead of centering it on a pitch, you centered it on a interval or kind of interval, a kind of chord identity almost, even though it's not a chord. So it's like the same, you take a concept from one style of music and apply it to a different style of music, or use the same concept to apply music which has superficially different application of that style. And I think that maybe that is one of the challenges for an artificial system, to be able to do this kind of learning that is not just echoing patterns, but actually kind of abstracting from them and being able to, after the abstraction, apply it in a different way.
Yeah, I think that that's a great point. And if you think about, let's just say you have a piece in the key of C, and you can go through and do the statistical analysis about how many times the pitch C shows up. And it's going to show up in the subdominant. It's not going to show up in the dominant. It's going to show up in the submediant. But what composers did over time was that they began to recontextualize that pitch C. So you see things like flat submediants or Neapolitan sixth chords or things like that. And that's, I think, what it would be really fun to see, a system that actually takes kind of those things that happened over, hundreds of years and begins to modelize and recontextualize, in this case, harmony.
Yeah. So kind of maybe think back at about some of those expert systems and think, well, maybe they didn't do quite as well as we would hope, but maybe they're in the core idea that it's something that is worth still keeping.
Yes, I absolutely think the core idea is something worth keeping, because if you know, listening to some of the papers, many people are drawing on rule-based systems. Many people are drawing on pattern matching and statistical analysis in ways that they're advancing artificial intelligence. So it's as if people are, that's why I wanted to give an historical context, that we are building our work on top of the work of others. And there are many people, but these, in my mind, they kind of fall into these classifications of rule-based systems or pattern matching systems, and now machine learning systems.
So Bob is sending us into a totally different direction about maybe as a from your perspective as a senior academic and teacher, how do you kind of vision for performing arts?
Yeah, so that's you know, I think that all of us have learned a lot by this pandemic, and the real, I mean, human suffering that is happening in quiet. Many of us isolated in our homes. In the case of students being on campus but isolated in their dorm rooms and not really having what many of us had as a college experience, is giving rise to a number of mental health issues that is actually something I want to model also in this piece, that in the piece about COVID, in that there are those very real constraints of somebody going into quarantine when they're diagnosed, and then they're sick, and then they're isolated. I think what has happened, and I think really any crisis also presents opportunity and a silver lining. So what I'm observing is that students, and again, we were just talking about this before we got together. I mean, different students are having different reactions to the pandemic. In some cases, you know, there's a greater sense of community, although it's a virtual community, not a physical community. And that what I observe is students and faculty are latching onto that as a way to try to cope with the pandemic. And I think what we're learning in terms of, I mean, just everything that's being done at this conference in terms of live streaming, in terms of Zoom, and I just got Zoom Pro myself, and I'm learning about the high quality rendering it can do for teaching in the arts. And I'm thrilled that you know, we'll come out the other end of this and we'll have better tools and hopefully a better sense of our own humanity as a result of it.
Thank you. I think our time is more or less up. So thank you again for joining us. And
Absolutely, my pleasure.
I believe the next session is another spotlight talk in half an hour or quarter of an hour by Holly Herndon. So thank you all for joining us.